separately heated in an open crucible. So now, when we are heating, for example, metals in open crucible, we said that metals will burn in air combining with oxygen, either oxygen or nitrogen. Either oxygen or nitrogen. So here now we have copper metal being burned in air. So when any substance is burning in air, it combines with either oxygen or nitrogen. So now copper will react with oxygen. Because now copper is a solid and it is burning in air to combine with oxygen to still form a solid. It means that now, because the end product is a solid, there is an increase in mass. There will be a decrease in mass.
Yes, hello and welcome. Mwalimu Juma, the number one channel for your education purpose. And from today, we'll be looking at Chemistry Kcse 2024. These are some of the questions that you have to be expecting in your forthcoming Kcse exams. So now we're beginning with looking at Chemistry Paper 1. And in this, I'm only with this one, I'm looking at the number ones that you are expected to be tested in that paper. So out of these 9 questions, one of them will be tested in the coming Kcse as paper 1 number 1. So take keen on it because it is of good help to you. So the first question that we'll be looking at is a question that comes from Form 1. It's a question that comes from 1, and now it is burning of metals in air. So the question is, when magnesium metal is burned in air, a white ash is formed. Write the formula of the 2 components of the white ash. So now, when we are burning a metal in air, the metal combines with the oxygen or nitrogen. So now when magnesium is burnt in air, it combines 1 with oxygen. It also combines with nitrogen. But now our question have been restricted that it is forming a white ash. So now the white ash that is formed, it is magnesium oxide. So we have to write the components in the white ash, which is the magnesium oxide. So when magnesium metal burns in air, to give a white ash. So it reacts with oxygen to form magnesium oxide. Now, this is the chemical reaction of the magnesium oxide. Now here we have magnesium, which is a solid, reacting with oxygen, which is a gas, to form magnesium oxide. Then we have to balance the equation, where now we have here 2 magnesium. Also on the right side you have 2 magnesium, then you have 2 oxygen. So now magnesium burns in air, reacting with oxygen to form magnesium oxide, which is a white ash. Now magnesium also burns in air, reacting with nitrogen, but now the component formed is greenish yellow in color. That's why now our question, we have been restricted to give the white ash formed. Now to our second question. which also comes from Form 1 on separation of mixtures. So we are being told the diagram below shows a setup of operators used to separate miscible liquids. Remember now, we have different mixtures. We have solid mixtures, we have solid liquid, we have liquid mixtures. So now here we are being told that the apparatus is used to to separate miscible liquids. These are liquids that already have mixed. So now this the process here is fractional distillation. Fractional distillation, where now we have the fractional distillation works on a condition that we have two liquids that are miscible, have different but close boiling points. Where now when we are heating, one that has lower boiling point will be the one to vaporize first, leaving the other one that has a higher boiling point. Now here we have our flat bottomed flask. Then now A is a fractionating column. You can see we have a thermometer being inserted into a fractionating column. Then inside the fractionating column, we have glass beads. Then the fractionating column is connected to a Liebig condenser. Then now the Liebig condenser has inlet and outlet. Now the thing that happens here, we have two miscible liquids which have two different boiling points but close. So the one with a lower boiling point will be the one that will vaporize first. So now the first question is name the part labeled A. So now the part labeled A, we said it is a fractionating column. Then part labeled B is a Liebig condenser. So part labeled A is fractionating column. Then part labeled B, it's a Liebig condenser. It's a Liebig condenser. Now part label B is a Liebig condenser, then part label A is a fractionating column. So now we have another question saying that state the function of the part labeled A. So now the part labeled A, which is a fractionating column, remember that the steam passes through the delivery tube where some of it condenses on the cooler part of the delivery tube to a colorless liquid. So now the steam is cooled and condensed to liquid. The steam is cooled and condensed to a liquid. So the cold water, for example, when we are using, when the miscible liquids that we are having is either water and ethanol, either water and ethanol. Now let's take that to be our example. Those are the liquids that we are having, the miscible liquids that we are having. The miscible liquids that we are having now to carry out the fractional distillation. So now we have water and we also have the ethanol. So now here, these two are already miscible. So you cannot tell which one is water, which one is ethanol. Which one is water and which one is ethanol. So the first thing that now happens, we provide heat where now the ethanol will be the first one to vaporize at 78 degrees Celsius, leaving water. So now any water vapor that will be vaporized before 100 degrees Celsius is reached, it will condense back to the round bottom, to the flat bottom flask. Reason being, we have glass beads. Inside the fractionating column. The fractionating column. So now the function of part A which we said is a fractionating column, is to allow water to condense into liquid and flow back into the flask before the boiling point is reached. Before the boiling point is reached. Remember now, the glass beads increases the surface for the water to condense back into liquid before the boiling point is reached. Before the boiling point is reached. Then on the Liebig condenser, remember on the Liebig condenser, we have an inlet and outlet. When the inlet and outlet are exchanged, we will still get the first fraction out, but now it won't be efficient as when the inlet and outlet are in their required position. When you exchange it, it will still we will still have our results, but it won't be efficient. So now the problem on exchanging the inlet and outlet on the Liebig condenser is that it won't be efficient, but now we'll have our results. So now the fractional distillation works on a rule that the two miscible liquids have different but close boiling points. Have different but close boiling points. Now to the next question. It is a Form 2 Topic 1 question. Element T has atomic number 9 while V has atomic number 11. Write down the electron configuration of elements T and V. So for writing the electron configuration for the first 20 elements of the periodic table, you know that the first energy level has a maximum of 2 electrons. The second energy level has a maximum of 8 electrons. The third energy level has a maximum of 8 electrons. So the first one is 2, the second one is 8, the third one is 8. Then now, as we proceed, we'll see that other metals, apart from the first 20 elements, will have more electrons in the fourth energy level. But now here we have the first, we have T that has atomic number 9. Remember, atomic number equals to the number of electrons in an atom. So now V has 11 as the atomic number. So for T, we say the first one takes a maximum of 2, and then the second one takes a maximum of 8. So having taken 2 to be the first maximum, we are remaining with 7. So now it is 27 for T. 27. Then V, we have 2 for first one, which is maximum. The second one is 8, which will give us a total of 10. We still have 1. So it will be 2, 8, 1. That's the electron configuration of V. We said for T, it is 2, 7. Then part B of that question says that state the bond formed when T and V combine. When T and V combine. So you can see that now we have T that has electron configuration of 2, 7. And we say that the second energy level has a maximum of 8 electrons. So now we can see that now the second energy level in T has less than 1 electron. And for V, it is 2, 8, 1. Now the third energy level is 1. It has less 7 to make it to maximum. But now, when T and V react, remember now, one will lose electron, another one will gain electron. So it will be easier for T to gain 1 electron than V to gain 7 electron. So now, V will lose 1 electron, which will be transferred to T. So now, a type of bond where there is electron transfer, we call it ionic bond. Ionic bond. It is ionic bond, where now there is a transfer of electron between the atoms. So now V has lost an electron, it has been gained by T, so that we can form the bond in between, which is ionic. Now to the fourth question. An element Y has the electron configuration of 285. Has electron configuration of 285. Identify its period. Now, in identification of period and groups, for us to identify periods, period is determined by the number of energy levels in that atom, the number of energy levels. So you can see that Y has electron configuration of 285. Those are three different energy levels. Three different energy levels, meaning that now it is in period 3. So for writing the period number, we write it using numerical number. If we could have been asked about the group is determined by the number of electrons in the last energy level. The group is determined by the number of electrons in the last energy level. For example, now to our element here, Y has 5 electrons in the last energy level. Now it belongs to group 5. But now 5, we indicate it using Roman number. If it could have been the group, we could have said it's group 5, but our 5, we write it using Roman number. But now because it is a period, we write period using numerical number, which is period 3, according to the number of energy levels that are filled. Now part B of the question says, write a formula of the most stable anion formed when Y ionizes. So now elements will form either an ion or a cation having lost or gained electrons. Now here an ion is formed because this element Y is gaining electrons. So element Y gains 3 electrons. Having gained 3 electrons, seeing to it that now electrons are negatively charged. So now the negative charge will be more as compared to the positive charge. Keeping in mind that the number of protons and the number of electrons in an element are all equal. So now, having gained more electrons, it means that we are gaining more more negative charge than compared to the positive charge available. At the beginning, the element or an atom is neutral because the number of electrons and the number of atoms are all equal. Having atoms that are positively charged and having electrons that are negatively charged, and they are all equal in number. But now here an anion has been formed whereby we are gaining more electrons. An ion is formed by the gaining of more electrons. So now here we have gained 3 more electrons. So now write a formula of the most stable anion of Y. In writing the anion of Y, we will indicate Y, then the number of electrons gained. The number of electrons gained, which are 3, then the charge. Because 3 has been gained, it means that now we have added 3 negative charges to the element to make it an ion. So now we have Y 3 negative. We have Y3 negative. Part C of the question says, explain the difference between the atomic radius of Y and the ionic radius of Y. So now, remember now, we are gaining more electrons. We are getting in more electrons. So now, the atomic radius will be small compared to the ionic radius. Atomic radius will be small compared to the ionic radius. Reason being, the existing electrons and the incoming electrons will exhibit a repulsion in between them, because now we already have the electrons occupying the energy levels, but now more are coming. So the three more that are coming will exhibit repulsion from the existing ones. So hence making the ionic radius to be more compared to the atomic radius. So atomic radius of Y is small compared to the radius of the ionic, compared to the radius of the ion, because it gains electron. Hence there is a repulsion between the existing and the incoming electrons, resulting in a large ionic radius. So now, what if we had an element that now was losing electrons? So now, when an atom is losing electrons, it means that now the atomic radius will be larger compared to the ionic radius, because now the last energy level that has been occupied, we are losing the entire of it. For example, when we have an element with the electron configuration of 281, remember now the last electron, the last energy level that has one electron, we are losing the entire of it, which means that now the atomic radius will be greater compared to the ionic radius. Question 5 is a Form 3 Topic 1 question. State Boyle's law. So Boyle's law states that the volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. Volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. Part B of it says that at 4000 degrees Celsius, 850 cubic centimeter of a gas exert a pressure of 560. What volume of the same gas will exert a pressure of 640 at the same temperature? Remember, we said that we are using the same temperature. The temperatures are constant. So now, in Boyle's law, we say pressure 1 multiplied by volume 1 will be equal to pressure 2 multiplied by volume 2. Where now we have our first pressure. We have our first pressure as 560, our first volume as 850, our second pressure as 640. Now we are looking for the volume 2, where now we'll take the first pressure multiplied by the first volume. Then we are dividing that with the second pressure, where now the volume for the second one will be 743.75 cubic centimeter. To the sixth question, name another gas which is used together with oxygen in welding. So that gas is acetylene. Then we are being asked question B, explain the change in mass that occurs when the following substances are separately heated in open crucible. Separately heated in an open crucible. So now, when we are heating, for example, metals in open crucible, we said that metals will burn in air combining with oxygen, either oxygen or nitrogen. So here now we have copper metal being burnt in air. So when any substance is burning in air, it combines with either oxygen or nitrogen. So now copper will react with oxygen. Because now copper is a solid, and it is burning in air to combine with oxygen to still form a solid. It means that now, because the end product is a solid, there is an increase in mass. There will be a decrease in mass if only the end product will be gas. If the end products are gases, we expect a decrease in mass. But because copper metal is burning in air, combining with oxygen to form copper oxide, which now is a metal, there is an increase in mass. When substances burn in air, they combine with oxygen to form oxides. Because the products are solid, there is an increase in mass. Because now our end product, in this case, our end product is a solid, there is an increase in mass. Because our end product in this scenario is a solid, there is an increase in mass. Could it have been that now our end product is a gas, there will be a decrease in mass, because now the gases will escape into the air. Hence now the final product will have a decreased mass. Then now copper 2 nitrate. Copper 2 nitrate. Remember now, copper 2 nitrate, we are subjecting it to heat, where now it will decompose. Copper 2 nitrate decomposes into copper oxide, nitrogen dioxide, and oxygen during this chemical reaction or during the decomposition. The mass of the copper 2 nitrate will decrease as the compound decomposes into different substances. Remember now, one, oxygen is a gas, nitrogen dioxide is a gas, so they will escape into air. So now copper 2 nitrate decomposes into copper oxide, which is a solid, that one will remain. Nitrogen dioxide, which is a gas, it will escape into air. And oxygen is a gas, it will escape into air. So now in this scenario, we remain with only copper 2 oxide. Now the copper 2 oxide will have a reduced mass compared to copper 2 nitrate, because some of the products are gaseous and have escaped into air, that is nitrogen dioxide and oxygen. So during this chemical reaction, the mass of the copper 2 nitrate will decrease as the compound decomposes into different substances, with copper oxide being the only solid, and the remaining gases will escape into the air. So now we have the two gases escaping into air. Now we are remaining with copper 2 oxide, which will have a smaller mass compared to the copper 2 nitrate. The seventh question, in extraction of zinc, the zinc ore is crushed to a powder mixed with oil and water and air blown through the mixture. Now we are being asked, what's the name given to this process? That is a froth flotation. Then part B of the question, explain how this process works. So in this process, finely powdered ore is mixed with either pine oil or eucalyptus oil. It is then mixed with water. Air is blown through the mixture with a great force. Froth is produced in this process. Which carries the wet ore upwards with it. So impurities are left in the water and sink to the bottom, from which these are drawn off. So now remember, at the beginning we have an ore of zinc. So where now finely powdered ore, the ore is crushed into a powder. It is either mixed with pine oil or eucalyptus oil. Then after being mixed with either of pine or eucalyptus oil, it is also then mixed with water. Then this mixture, air is blown through it with a great force. Air having blown through it, a froth is produced. A froth is produced, then that carries the weight or upwards. So now the impurities are left in the water and sink to the bottom, from which are drawn, from where now the impurities are drawn. So now to see part of the question says, we name the chief ore from which zinc is extracted. That is zinc blende. That is zinc blende. So give two differences between a thistle funnel and a dropping funnel. So you have different types of funnel. So in this case, we have we are being asked to give difference between a thistle funnel and a dropping funnel. So the difference number one is that dropping funnel has a tap, while the thistle funnel does not have. So the dropping funnel has a tap. The difference number two is that dropping funnel can be used to deliver liquids dropwise, while the thistle funnel cannot. So because it has a tap, we can regulate the tap to deliver the liquids dropwise, as compared to the thistle funnel, which does not have a tap. It will be hectic for us to deliver the liquids dropwise. Then dropping funnel can be used in separating of immiscible liquids, while the thistle funnel cannot. So because it has a tap, when we have two immiscible liquids, these are liquids that cannot mix, that will form a layer at their meeting point, will form a layer, for example, water and paraffin. So water and paraffin are immiscible liquids, so we can separate them using a dropping funnel, where now the first layer will draw it out. Then now the meeting point will discard it, then have the last layer again being drawn out. Now to our last question, state two laboratory rules that should be followed to avoid contamination and wastage of chemicals. Remember, now this is not a general question that we state the rules, we state the laboratory rules, but we are being restricted to the rules that will avoid contamination and wastage of chemicals. 1. Keep your hands away from your face, eyes. Remember, one is contamination and wastage. Keep your hands away from your face, eyes, mouth, and body while using chemicals. So when you are using chemicals, for example, you have touched them, then you start touching your eyes. Having touched the chemicals can either cause irritation to your skin. Then now that means that that chemical is already wasted. That chemical is already wasted. Then food and drink, open or closed, should never be brought into the laboratory or chemical storage area. Because now, for example, food particles can drop into the chemicals, hence that chemical is contaminated and can no longer be in use. They never use laboratory glassware for eating or drinking purposes, because already those glasswares may be containing the chemicals. When you use them, the food is already contaminated with with the chemicals. So do not apply cosmetics while in the laboratory or storage area, because now either your cosmetics can come into contact with the chemicals, hence rendering them not useful anymore. So those are the possible number one question that you have to expect in the coming 2024 Kcse Chemistry Paper 1. Thank you for watching, liking, subscribing, and be blessed.